All right, welcome back, everyone, to the deep dive. We've got a really interesting one lined up today. I'm really excited to talk about this. We are talking about dynamic visuals, so things like animations, videos, those things that are really meant to help you learn and understand complex topics.
Yeah, exactly. I mean, you see them everywhere, right? Like explaining how lightning works or how an electric motor functions.
Oh, yeah.
Even things like how to solve probability problems or how to properly administer first aid, right? Like those kind of step-by-step procedures. It seems like watching something unfold should just, you know, make it instantly click in your head.
Right. It feels so intuitive. Like, of course, a video of an electric motor being disassembled and explained is going to be better than just a static diagram.
Yeah, you would think so.
But research is finding that that's not always the case, especially when those dynamic visuals get really complex. They're not always better for learning than simple pictures.
Yeah, and that brings us to what we're really digging into today, this idea of segmentation. So we're going to look at how breaking down those animations and videos into smaller parts can actually help you learn more effectively. So instead of just a continuous stream of information, you get these smaller chunks shown one after another with little pauses in between.
Right, right. And so in this deep dive, what we really want to do is understand, like, why is this so effective? Like, what's actually happening in the brain that makes learning complex stuff easier when it's presented in these bite-sized pieces?
Exactly, yeah. And there are two main ideas that we're going to explore today that could kind of help explain this effect. They're not necessarily mutually exclusive. They kind of work together.
Okay.
We'll delve into each one.
So let's dive into the first idea then.
All right, so the first one is how segmentation can help reduce that feeling of being overwhelmed.
Okay.
Like that cognitive overload that can happen when you're just bombarded with a constant flow of information, like when you're watching a dynamic visual that just doesn't stop. One of the things to keep in mind here is that animations and videos, they're transient by nature.
Right.
What you just saw, it's gone, and then something new pops up right away.
Poof.
And that can be challenging for your working memory, which is kind of like a mental notepad,
Uh-huh.
right? It only has so much space. It can only hold and actively work on a limited amount of information at any given time.
Oh, yeah, like trying to cram for a test, and you've got all these different concepts and formulas swirling around in your head.
Exactly, exactly. And when you're watching a video that just keeps going and going, new information keeps coming in, and your brain's working hard to try and keep the earlier stuff in mind while also processing the new bits.
Yeah, it's a lot to juggle.
It is. It is. And that's where this idea of the time-based resource sharing model of working memory comes in.
Yeah.
It basically suggests that your mental focus, your ability to juggle all those balls, is limited. You can really only pay close attention to one thing at a time. So when you're learning from a dynamic visualization that's constantly in motion, your attention is having to rapidly switch back and forth.
Back and forth
Between keeping the information you just saw active in your mind, but keeping that ball in the air, and catching and processing the new information that's coming in, like the next ball being tossed to you. And if that video is fast-paced, that switching has to happen so quickly that it can really drain your mental energy. It's like trying to juggle way too many balls at once. You're bound to drop a few.
Yeah, and I think that's where this idea of cognitive load comes into play, right? We have the inherent difficulty of the material itself, the intrinsic load,
Yes.
and then there's the load created by how that material is presented to us, the extraneous load.
Precisely. So the intrinsic load is really about the complexity of the information itself. Like learning a simple list of terms is going to have lower intrinsic load than understanding how those terms all work together
Yeah.
in a really complicated system.
Right, right. So extraneous load, on the other hand, is kind of like the mental effort that's put on you by things that aren't actually helping you learn the core stuff.
Yeah.
Things like a confusing interface or an animation that just throws way too much at you without a break.
Exactly, yeah.
And so how does watching a dynamic visual without any breaks contribute to that extraneous load? Like, how does that make it harder to learn the essential stuff?
Well, because that continuous flow of information just keeps your working memory under constant pressure. You're trying to process the new stuff while still holding on to and making sense of what you just saw.
Uh-huh.
And that rapid influx of information can just overwhelm your mental workspace, right? You're using up mental energy on demands that aren't directly related to understanding the core concepts. It's like trying to read a really important email while someone keeps interrupting you. You have less mental space to really focus and absorb what matters.
It's like trying to have a conversation in a loud, crowded room.
Exactly.
Yeah.
So much mental effort just to filter out the noise.
Right, right. So how does breaking that continuous flow segmentation help with all of that?
Well, by dividing the animation or video into those smaller chunks, those more manageable bites,
Mm.
and then putting those pauses in between, segmentation gives your working memory a chance to catch up and consolidate what it's just encountered.
Right.
It's like taking a breath between complicated instructions, giving yourself a moment to think, okay, what did I just see? What did I just learn?
Yeah, it's like having time to actually digest the information, let it sink in.
Exactly.
Yeah.
And there was a really interesting study done by Hasler and colleagues back in
I
2007.
remember reading about that one.
Yeah. What was really cool about their study was they controlled for the total amount of learning time. So everyone got the same amount of time to study.
Okay.
But the group that learned with a segmented animation, they actually performed better on the more difficult test questions. And even the group that had the option to pause a non-segmented animation, even though most of them didn't use that pause button, they still did better.
Interesting. So it suggests that it's not just about having more time overall.
Exactly. It's really about those strategic pauses, right?
Yeah.
Allowing for better processing at key points in the learning process.
But it's not like a one-size-fits-all solution for everyone, right? Because there's this thing called the expertise reversal effect.
Oh, you're absolutely right. Some studies have found that breaking things down was super helpful for learners who didn't have a lot of prior knowledge about the topic.
Right.
But people who already had a good understanding, they didn't seem to get as much benefit from segmentation. In some cases, it even seemed to hurt their performance a little bit.
Huh. So if you're already familiar with the material, those imposed breaks might feel unnecessary.
Exactly. You're kind of already breaking it down naturally in your head.
You've already got those mental chunks.
Exactly. So that's kind of the cognitive load perspective, how segmentation can help with that.
Okay, so we've tackled that first idea, the cognitive load, and how segmentation helps with that. Let's move on to the second big idea.
All right, so the second idea is about how breaking down dynamic visuals can help us understand the underlying structure of what we're seeing. And this relates to this theory called event segmentation theory.
Okay.
It suggests that our brains naturally break down these continuous events into smaller, more meaningful sub-events or steps. Like, think about watching someone making a sandwich. You don't see that as just one long, unbroken action, right? You mentally divide it into, like, taking out the bread, spreading the mustard, adding the fillings, and so on.
Right.
Our minds are constantly looking for those natural breaking points.
So our brains are always trying to find these event boundaries, these kind of mental chapter breaks.
Exactly.
Mhm.
And event segmentation theory, this is developed by Zach and his team, it proposes that we build these mental models, these event models, based on what we see and what we already know.
Okay.
And we use these models to predict what's going to happen next. And when our predictions don't match the new information coming in, like maybe there's a change in movement or speed or a sub-goal is completed, our brain registers that as an event boundary. Like, oh, something different is happening now.
Okay, so it's like a mental shift.
Yeah, exactly. And it starts to create a new model for this next part of the event.
So how does this natural way our brains segment events relate to learning from dynamic visualizations? Like, how does that tie in?
Well, when those instructional dynamic visualizations are segmented, those pauses and those clear divisions can act as what we call temporal cues.
Okay.
They're basically highlighting those natural event boundaries for you, the learner.
So it's like the animation is mirroring how our brain already wants to break down the information? Precisely. And by making those boundaries more obvious, segmentation can really help you see that sequence of steps and how they connect to each other more effectively. It provides this clear roadmap of the process, making it easier to follow along and understand that bigger picture.
This reminds me of Catronbone's work on learning from worked examples.
Oh, absolutely, yeah.
Like when you're trying to solve problems.
That's a great connection.
Yeah.
So Catronbone's work back in the 90s showed that when those steps in a worked example were visually separated and labeled, people learned way better.
Yeah.
They could apply that knowledge to new problems more effectively. And segmentation in dynamic visualizations, it's a similar idea, but instead of that visual separation on a page, it's a temporal separation in time.
Right, right.
But both approaches really help to highlight those individual components of a process and how they fit together.
And it feels like this clearer segmentation might also encourage us to think more deeply about each part. Like to explain to ourselves what's happening and why at each step.
Uh-huh.
Absolutely. When that information is presented in these smaller, more digestible chunks,
Right.
and there's that built-in time to process each one, it creates a much better opportunity for you to actively engage with the material.
Right.
You're more likely to kind of internally explain those relationships between the steps and build a deeper understanding. But again, going back to that expertise reversal idea, if you already have a strong mental model of the process, those explicit cues might not be as necessary for you.
Right, right. It seems like these two ideas, reducing cognitive overload and helping us see the structure, really work together to make segmentation effective.
Yeah, they do. They really do. And in most of the research that's been done, segmentation involves both putting in those pauses and clearly indicating where one segment ends and another begins.
Uh-huh.
So it's often hard to tease apart exactly how much of the benefit is coming from the pauses themselves versus how much is coming from those temporal cues that highlight the structure.
So it's still a bit of a mystery as to which one is more important, or if it's really the combination that creates that magic learning effect.
Exactly. That's definitely an area where more research is needed. Like, to really understand the independent effects of pauses and those temporal cues, you need to compare different versions of dynamic visualizations.
Okay.
Like some with just pauses, some with visual cues for the breaks, but no pauses, and then some with both.
Yeah, that would be really interesting to see. What about the different types of dynamic visuals? Does breaking them down have the same impact across the board? Like, is segmenting an animation of a chemical reaction the same as segmenting a video of someone, performing a physical skill?
That's a really great point. The effectiveness of segmentation might very well depend on the specific type of dynamic visual that you're looking at. For example, if it's a common everyday activity, something that you already have a lot of mental models for, breaking it down might have a different effect than if it's a really complex, unfamiliar natural process, something that's totally new to you.
Right, right. And I remember coming across some information about mirror neurons and how we process videos of people moving.
Yeah, that's a fascinating area of research, and it might play a role here as
Yeah.
well. So the mirror neuron system, it's activated when we watch other people perform actions, and it might be involved in how we mentally break down and understand those kinds of visualizations.
Some researchers have suggested that it might make mentally segmenting visualizations of human actions more automatic
Okay.
compared to, say, an abstract mechanical process. So that could definitely influence how much segmentation helps in different contexts.
This brings up another question for me.
Yeah.
How long should these segments be? Is there like a sweet spot, a Goldilocks length for a segment?
That's a great question. And the research kind of suggests that there might not be a single answer that applies in every situation.
Yeah.
A study from 1992 by Boltz, they looked at how commercial breaks in videos affected memory. And that hinted that the length of those breaks, which are essentially segments, can actually impact recall.
Okay.
So it's possible that if you're a beginner learning something brand new, shorter, more focused segments might be more helpful.
While someone with more experience might be able to handle and maybe even prefer longer segments that align with more complex sub-events.
So it's like when you're learning to drive, those first few lessons, you need to focus on each tiny step.
Exactly. Check
Yeah.
your mirrors, signal, look over your shoulder. But
Right.
as you become more experienced, you can kind of group those actions together into smoother, more fluid sequences.
Yeah, yeah, I see that. This leads to another interesting question, though. What if learners were able to segment the dynamic visualizations themselves?
Ooh, that's a really cool idea.
Hmm.
That could be a form of active learning that really enhances understanding.
Right.
Some researchers have proposed that being able to interact with those dynamic visuals in that way to kind of choose your own adventure with segmentation could lead to deeper processing.
Okay.
So if you're actively identifying and creating those segments yourself, you're really engaging with the material. And that could be particularly helpful if you already have some prior knowledge.
But it also seems like it could be tricky, right?
Yeah, it's definitely a balancing act. You have to consider whether learners have enough mental resources to both figure out where to segment and learn the content at the same time.
Right.
If the act of segmenting itself becomes too difficult, it could actually hinder learning.
So we need to make sure it's challenging but not overwhelming.
Exactly.
And beyond what we already know, what other individual differences between learners might affect how well segmentation works?
Oh, there's so many factors to consider. Things like how motivated you are to learn, your spatial abilities, which might be particularly important for understanding things like mechanical systems, and even your age could all play a role. We still need a lot more research to fully understand all of these different interactions and how they influence the effectiveness of segmentation.
So, to bring it all back together, what are the key takeaways about why breaking down dynamic visuals seems to be so helpful?
Well, the research really points to two main benefits. First, By including those pauses, segmentation reduces that mental strain of trying to process a continuous stream of information. It gives your brain a chance to breathe, to really absorb what you've just seen.
Okay.
And second, by clearly marking those boundaries between the meaningful parts, segmentation provides those cues that help you understand that underlying structure.
Mhm.
It makes it easier to see how the steps in a process connect and flow together.
So it's about giving our brains a break and giving us those clear signposts to understand the journey.
Exactly. The pauses help with processing efficiency, and those temporal cues really enhance our structural understanding.
Yeah.
And while we're still learning about how those two things interact, it's pretty clear that both of them contribute to the positive learning outcomes we see with segmentation.
That's really fascinating. It makes you think about how this idea of breaking things down into smaller chunks with pauses could be useful in so many other areas of learning, even just in processing information in our daily lives. Oh, absolutely. Like, think about tackling a big project, breaking it down into smaller, more manageable tasks, and taking those deliberate pauses to reflect after each step. That could be a real-world application of these same principles.
Right.
Or even when you're reading a dense report, taking breaks between sections to summarize and process what you've just read can really make a difference in how much you retain.
Definitely something for all of us to consider. So for our listeners out there, I want you to think about the dynamic visuals you've encountered in your own learning. Were they segmented? Did you even notice it at the time? And how did it affect your ability to understand and remember the information? We encourage you to think more about this based on what we've discussed today.
Yeah, I think that's a great takeaway for everyone.
And as always, thank you so much for joining us on this deep dive. We'll see you next time.